Hello everyone, welcome to day 2 of graphing two-variable inequalities. The difference between today and yesterday is that today we're not always going to give you the equation in standard form. Sometimes you'll have to change it to standard form, and other times you can just graph it as it is in slope-intercept type form. So let's do the first one first. We need to change this so that it's in standard form, which means put the x first. Y was positive, so we're going to be adding it, and we want to be less than 2. If we solve for the two intercepts, if I put 0 for y, that would be negative 2x equals 2. You solve for the intercepts by making it an equal sign. We'll divide by negative 2, and that'll give us x is equal to negative 1. To find the y-intercept, we'll put 0 for x, and that'll leave us with y equals 2, and that's it. That's the entire intercept, y equals 2. So now let's see which of these graphs matches y is equal to 2 as one of the intercepts, and x is equal to negative 1 as the other one. This one has y is equal to 2, but it has the incorrect x-intercept. B has the right intercept and the right intercept. And if we look at the inequality, we see that it doesn't include negative 2. Sorry, it doesn't include 2. We want to be less than it. That means we should be using a dashed line. And letter B is using a dashed line, so it is the correct inequality. And question number 2, y is less than or equal to negative 3x. Well, if we just look at that inequality, the slope is negative, so we need to be going down, and it's a negative 3, so it's going to be kind of steep, but it's going to be going through the origin. We're not adding anything for the y-intercept, so it's going to be going through the origin with a negative slope. The only one of these graphs that goes through the origin is letter D. D has a solid line, so let me just make sure that in question number 2, we have an or equal to sign, and we do. So number 2's answer is D. In number 3, we need to first start off by changing it into standard form. We put x first plus 2y greater than or equal to 4. Then we'll solve for the two intercepts. Let me put 0 for y first. Negative x is equal to 4, which means x is equal to negative 4. That's the x-intercept. The y-intercept would be 2y equals 4. That means y is equal to 2. So I should be able to find a y-intercept of 2 and an x-intercept of negative 4. And I think that's letter A. It looks like it. We see a solid line for answer choice A. Let's make sure. Number 3 does have or equal to, so it is a solid line. This means solid line. This would mean dashed line. X plus y is greater than 1. Means we should have two intercepts of 1, like in letter C. And we should have a dashed line, which is correct. 4 is C. 3 was A. And that's how you choose between multiple choice which graph matches the inequality. Now let me just show you how you can graph with slope-intercept form of inequalities. If I have a negative 5 here, that's my y-intercept. So at negative 5, I should have one of my points. Then let's look at the slope. The slope is equal to 1 because how many x's are right there? It's only one x, and the number in front of x would be the number 1. 1 times x is simply x. So that means if I go one space over, I should go one space up. And that's the way this line is going to be going. Then we need to see right there, is it equal to? If it says or equal to, something or equal to, that means you can use a solid line. Then we need to pick a test point. The last thing we do is pick a test point. 0, 0 is the easiest one. 0, 0, we're going to put that for x and y. 0 greater than or equal to 0 minus 5 is 0. Sorry, I just got distracted and wanted to put some arrows on my graph. Is 0 greater than or equal to negative 5? Yes, it is. So we should shade this side of our graph. Everything on this side of my graph is going to be equal to, well, it's not going to be equal to something. It's going to be a solution. Those are going to be the correct solutions for the inequality. On your paper, go ahead and try number 7 and pause the video because I'm going to show you the answer in just a moment. Okay, let's get that answer. We're going to go through the origin, and because our slope is 3, every one we move to the right, we should go up by 3. Since here it does not have or equal to, this is going to be a dashed line. And a dashed line means the numbers on the line are acting like a boundary and they're not going to be actual solutions to the inequality. Now we need to see, are we going to shade above it or below it? Well, since 0, 0 is on the dashed line, I can't pick that. I have to pick some other random point. I'm going to pick negative 2, 2. That's a 2 for y, and we want it to be greater than 3 times negative 2. 2 greater than negative 6. Yes, 2 is greater than negative 6, so I will shade this side. Because that was true, whenever you plugged in the point, right there, that orange point, because that orange point was true, everything on that side of the line is also going to be a correct solution for the inequality. Let's just do a couple more. Okay, number 10. Y minus x greater than 1. Let's change that to be negative x plus y greater than or equal to 1. My x-intercept will be negative 1. My y-intercept will be positive 1. So I have that, and I have this. And my symbol shows that I can be a solid line. So let me draw a solid line going through those 2 points. And then now let's find out the shading. Since 0 is not on the line, we can use that as our test point. 0, 0. Is 0 plus 0 greater than or equal to 1? That's not true, so we will not shade the numbers that are on the same side as 0, 0. We'll shade these ones above the line. What if I give you the graph? Well, if I give you the graph, you probably won't be writing these in standard form. If you're given the graph, you should find the y-intercept and find the slope. Here are 2 points, and the run is equal to 1, and the rise is equal to 3. So if we put the rise over the run, that will be equal to the slope, and that'll be equal to 3 over 1, which is just the number 3. We're then going to write y equals mx plus b. Y equals 3x, and then this was my y-intercept, and that was at negative 3. So I'm going to put negative 3 for b. And now we need to find out, are we shading above it or are we shading below it? So we need to pick something that was true. Pick something from the shaded area. It must be true. That point is 2, 1. That's a 1 for y and a 2 for x. Okay, but we're not going to be equal to. We're going to be something else. we don't know. We want something to be true, but we don't know what symbol we're going to put. So let me use a different color. We need the number 1, and then we have 6 minus 3, which is going to be equal to 3. So I have 1 on the left and 3 on the right. We need to write some sort of symbol in between these two numbers so that it's true. And that would be a less than sign. Then let's look at the line. That's a solid line, so we're going to have to put an equal to also. So that means the actual correct inequality for this graph would be y is less than or equal to 3x minus 3. Let's do a few more. Here's a dashed line, so we know it's either going to be this one or this one. It's not going to be equal to. Let's look at the y-intercept. B is going to be equal to 1.5. So y equals something times x plus 1.5. We need to find the slope. M is equal to, let's use some good points. There are some clean ones right there. We're going to go down 1 over 2. Minus 1 over 2. That was the rise. This is the run. We're going to have negative 1 over 2, which means a 0.5 is the slope. While editing this, I saw that should be a negative 0.5. Now, we're going to pick something from our shaded part and use it as a test point. I'm going to pick 1, negative 1, negative 1 for y. We're going to leave a blank space because we don't know if we're going to put greater than or less than there. But I'm going to do half of 1 for x plus 1.5. I'm going to follow it down. Negative 1. 0.5 times 1 is 0.5 plus 1.5. That's going to give me the number 2 on the right and negative 1 on the left. Negative 1 is less than 2. So that's going to be the symbol we're going to write at the top. Y is less than half of x plus 1.5. Again, now that I'm editing this video, the slope should be a negative 0.5 times x, but the inequality that I wrote is correct. Let me go ahead and box this other final answer too. Okay, I'll do one last example. The easiest thing to start off with is the y-intercept. This one's 4. It's a positive 4. Then find the slope. So we need 2 points. And it looks like we're going to go over 1, up 2. That's a slope of 2. Then write it into y equals mx plus b format. So 2 times x plus 4. Then you're going to pick something from the test point area, something that's shaded. I'm going to pick negative 2, comma 4. 4 for y. 2 times negative 2. Oh, I messed up. We're not putting equals because we want it something. It's not going to be equal, but it's going to be something that's true. 2 times negative 2 plus 4. That's negative 4 plus 4. That's a 0 on the right and a 4 on the left. 4 is greater than 0. So that's the statement that's going to be true. We're not finding the ones that are equal to. We're finding the ones that are greater than 2x plus 4. I hope this video made sense to you. As long as you're able to graph these, this should be pretty fine. There you go. I mean, just look for the intercepts, find the slopes, then pick a test point and see what makes it true. In this case, 0, 0 was true. So once you're good at these, you can solve it in like 20 seconds or less. But for right now, I would expect your practice to take you between 12 to 30 minutes. Good luck on your assignment.